So we are starting on our first topic, limits in calculus. And we're going to look at it in a couple different approaches, looking at it graphically, looking at it algebraically. So I just want to go through a couple things with algebra, things that you'll need to know to help you with what we're going to talk about right now. So recall when you're writing a point, right? Two variables, we could write it as xy. Well, we're going to use pretty much function notation, and so instead of y, a lot of times we're going to write that as f of x, g of x, h of x. So if we call that f of x notation is the same thing as the y value of your point. So if I had some graph here, vertical is our y-axis or f of x, and the horizontal line was our x-axis. And maybe we have some graph in here. And it said find f of. So you need to understand this notation. So this 4 is representing the x value of your point. So you're going to go over here on the x-axis, locate where 4 is, go up on the graph, and we're trying to figure out what the y value is when x is 4. So looking at this, we can see that the y value here is 2. Chat, so just want to make sure there's no problems. So any questions about that notation? So another way that I could have written this, if I was looking at this graph as a point, there's a couple ways. So I could say this is the same thing at x. When x was 4, my y value is 2. Or if I wrote it like this, when x is 4, I can write f of 4 here. So we know f of 4 is 2. So when we're looking at limits, we're looking at what's happening in the graph as we're approaching some x value. So sometimes, let's say I want to see what's going on with my y value as we get closer and closer to x equals 4 on the graph. So for instance, I would locate, if I was looking at a limit, and I'll go through the definitions a little more in a second. But if I wanted to know what was happening as x is, our y value is x is getting closer, your value is getting closer and closer to 4. So we're coming in on the left-hand side, and we're getting closer and closer to x equals 4. Notice that that y value is getting closer and closer to 2. If I chose something like this right here, like 3.9, and I plugged it in to the equation, I don't have the equation in front of me, I would get some value right below here. And that would be getting closer and closer. As I get closer and closer to the 4 value on the left, it would be getting, my y value would be getting closer and closer to this 2 value. We're looking at also what's happening. You have to look at both sides when you're looking at limits as you're approaching some x value. And so if I'm looking at what's happening on the graph, as I'm getting closer and closer to x equals 4 on the right, so maybe 4.1, maybe 4.01, 4.001. As I'm getting closer and closer to this 4 value on the right, notice again, we're approaching the y value of 2. And so we're going to be looking at different functions and graphs and find out what the limit is as we're approaching some x value. What is that y value we're approaching? So sometimes I'll post notes that you can follow along with. Sometimes I won't. But here you could find some notes that were I posted last night on week 1 of the modules. And then you, if you want, you can go through and fill these out while you're watching. Okay, so what is a limit? So a limit is the y value of a function that approaches from both the left and the right side of a given x value. Okay, so looking at the following graphs, we want to look at the limit and the value of the graph. Before I do that, let me give you some notation on how to write a limit. Okay, so if I want to know what's happening to my graph as x is approaching, and the last example was 4, how I would write that is the limit I would write as lim. And then below is the variable you're using, what x value, and we're not always x as the independent variable, that horizontal axis, maybe it's time. But you would put that variable you're using down below, an arrow, and then a 4. And then whatever function you're using, so we were talking about it as f of x. This says the limit as x approaches 4 of f of x is equal to. Okay, so I see that there are chats coming through, so let me just pause the recording and make sure everything is going okay.
I have a question real quick.
Yes.
For the fill-in notes, I went to go look for it, and it says that it's what is the exact wording? The file is part of an unpublished module and is not available yet.
Okay. Okay, so let's look at this. Okay, so we had to pause for some technical difficulties. So you haven't been able to get these notes right away, but I will fix that in Canvas, and you should be able to soon. So looking at the following example, we have this graph here. Let's look at example 1. So we have an upside down parabola, and right now it's saying find this f of -3 in here. This is saying look at your graph. So when x is -3, so looking at the horizontal axis, locate x equals -3. And then it's wanting to know what is the y value when your x value is -3. So look at the graph, go up to the picture of the graph, and that would tell me my y value here is 4. So the notation below this f of -3, this lim, and then x with an arrow, -3, and then on the side of that is f of x equals. So what this is saying is we want to see what's going on with a graph as we approach x equals -3. So we want to see if I'm coming in on the left-hand side of this x equals -3, what is my y value going to be? So for instance, if I wanted to look at -4 is on the left of -3. If I looked at f of -4, I would get a value of 3. If I look at f of -3.5, I would get a value of about 3.5. And as I'm getting closer and closer to this x value here of -3, I'm getting closer and closer to that y value of 4. In order for a limit to exist, it has to approach the same value both on the left and the right. And so notice on this graph, if we're looking at values of x to the right of -3, bigger numbers, and -3, but getting closer and closer to our -3 value, I would follow the picture on my graph, getting closer and closer to that x value in here of -3, and see what is my y value that I'm getting closer and closer to. And so notice this y value that we're getting closer and closer to is also 4. And so we would say the limit exists because both the left-hand side and the right-hand side are coming to the same value as we approach x equals -3. So we would say that this limit as x approaches -3 is 4. So notice the graph to the right is almost identical to the one that we just looked at. The only difference in this graph is this open circle. What does that open circle mean there? Well, it's telling me that there's no point there. I sometimes would look to see, is there a point that's above or below where the graph is heading towards? Like notice the third graph, notice there is a point below that. But I don't see any point above or below this parabola at x equals -3. And so because there's no point there, we would say that this actually does not exist. So I'm going to put D in E for does not exist. But if we're looking at the limit, as x is approaching -3, it's still approaching that y value of 4, right? Because if I put in x equals -4, a value on the left of x equals -3, smaller, I hit again 3. If I go to -3.5, I hit 3.5. If I hit maybe -3.1, so it would probably be like something like 3.99. So as I'm getting closer and closer, I'm never going to reach there because it doesn't exist. But that value I'm approaching is still 4. If that's happening on the right-hand side too, then that limit actually does exist, even though it doesn't, that there's no point there. That value of x is undefined. So coming in on the right-hand side of x equals -3, values that are bigger to -3, as we get closer and closer, so let's say x equals -2, notice that we have, let's say 3. If we do -2.5, we have 3.5. So again, as we're getting closer and closer, so maybe -3.1, -3.01, -3.0000001. So we could go on forever, right? And as we're going on forever, getting closer to x equals -3 on the right, our value we're hitting is 4. So our limit does exist, even though the function doesn't exist at that value and is 4.
Professor,
Yes.
it's cutting out really bad.
Shoot, that's not what I wanted. Okay, so let's see, hopefully this works better and you guys can hear me better and not the clicking. So now let's look at that third graph, f of -3. So again, same as the other ones, we're looking at when x is -3, what is that y value? So we have an open circle on this graph, just kind of making it larger so you can see that. And we actually have a point below here. And so we're looking at what is our y value when x is equal to -3. Well, our y value here, so if I go up to this point, I can see that my y value is 1. So f of -3, I would write as equals 1. So we want to know what is the limit, though, as x is approaching -3. So again, we want to look at what's happening to the graph as we are approaching that y value of -3. And so what's happening as we're approaching this y value of -3 on the left, again, even though the point's down here, the graph is approaching the y value of 4. Again, looking at what's happening on the right-hand side of the graph. So even though it's not, this f of -3 is not 4, the graph is approaching that y value of 4. So the limit is actually 4. Okay, so the fourth graph that we're looking at is not a parabola anymore. And so we have a piece that is increasing. Our graph is going upwards as we're approaching x equals -4. So it's increasing there. It's actually increasing here. There's just this jump in our graph at x equals -3. So f of -3, again, you want to look at what is your x, when x is -3, what is your y value? So notice this bottom point, it's solid. That's your y value. Your y value in this case is 1. If you look at the piece on the left, that graph on the left of x equals -3, that is has an open circle. And so that's saying it's not existing there. The limit as x approaches -3 actually doesn't exist. And that's because, again, the left-hand side and the right-hand side aren't going to the same y value or approaching that same y value. So if I was looking at the limit, LIM, as x is approaching -3, so that arrow with a -3, I'm going to write the notation so it's just telling me that I'm coming in on just one side. So one side of
Is that just her?
okay, I see myself moving again.
I don't.
So looking at, okay. So let's actually stop here today. Let me just pause the recording or stop the recording and talk to you guys a little bit.
Professor,
I think she's frozen.
Yeah, I can only hear you guys. Can't see anything.
You won't even let me stop the recording probably.
Zoom is an experience for sure. Oh my gosh. Are there other people here?
She may end the task of this Zoom meeting, so it may close the Zoom meeting. Yeah, she's gone. Some Brenna Barnes is now the host. I do not know who that is.
Oh, see you guys Thursday.
I think so.
You'll probably come back.
Maybe. If
What are we
anything,
gonna
her internet may be disconnected, so it could take, anywhere from 30 to an hour, or if it's really that bad.
Do we leave?
If
Yeah, do we leave?
Yeah, I don't know.
I mean, I'm not a professor, but
I mean, we
Uh,
only have 9 minutes left of our class time, so.
yeah, I don't think there's much to do.
Well,
I think she needs to get AirPods. I hate to say it, even though they're kind of a ripoff, they like pick up just the voice, which is perfect. So,
Yeah.
and they're close to a mic close to her mouth, and it needs to be closer. It cannot be on a table.
Yeah, I think if you buy cheaper mics, sometimes they don't work. You got to read like the list of top 10 mics because
Even some of the mics that are like good, like $40, $30, you can probably find.
yeah, I have a couple that I'm gonna recommend to her because I just have that knowledge. So
Yeah.
I'll let you know
Probably good to let her know.
we need some audio that's better than this.
If you
The people-
guys want to leave, I'm gonna stay just because I'm not gonna be on my computer. If she comes back, I'll just tell her everyone left.
Okay.
If you want
Bye.
to leave.
well,
Are you
bye.
guys? Did you guys understand
Yeah.
what she's saying? Oh, she's back. Okay.
Oh, she's back. Yeah, she's now the host. Okay.
Okay, so technical difficulties. Let me just stop now. You might have heard or not heard. Let's just stop the lecture for today. And then hopefully things will be better on Thursday.